All right, today we're diving into something really bold. It's a new contender for a theory of everything, and it's called Duhon's looping motion. The goal here? To basically rewrite the entire story of our universe, from the very first spark to, well, everything we see today. So let's get into it. To even begin to understand this, we have to start with a huge, kind of provocative question. I mean, for decades, the Big Bang has been the bedrock of cosmology. But what if its most fundamental idea, this single, infinitely dense point exploding out of literally nothing, what if that's the part we've gotten wrong all along? You know, the biggest problem in physics today, it's like a civil war. On one side, you've got Einstein's general relativity. It's beautiful, it describes the huge, smooth universe of planets and galaxies perfectly. Then on the other side, you've got quantum mechanics, this bizarre, pixelated world of tiny particles and forces. They both work incredibly well in their own domains. But here's the kicker. They just don't agree. They're fundamentally incompatible. And that conflict right there is the source of pretty much all the biggest unsolved mysteries in science. It's what keeps physicists up at night, hunting for that one single elegant theory that can finally bring these two sides together. And that whole search, it really has to start at the very beginning. And there is no greater mystery than the beginning itself. See, the standard Big Bang model says everything started from a singularity, a point with zero size and infinite density. Now, what's the problem with that? Well, at that exact point, all our laws of physics just break. They stop working. The math spits out nonsense infinities. How can everything we know come from a place where physics itself doesn't even exist? So this is where a radical new idea comes onto the scene from an independent researcher named Jonathan Duhon. And instead of trying to just patch up the old story, it suggests a completely new engine for reality itself. The entire theory actually sparked from this really simple, almost childlike question. What if true zero just doesn't exist in nature? Because something can't come from nothing, right? So what if the universe isn't a one-time explosion, but more like a continuous, rhythmic beat? Like an instinctual tick that's just always been there, preventing reality from ever crashing into that impossible zero. And that simple question grew into what he calls Duhon's looping motion, or DLM. The core idea is honestly breathtakingly simple. It says there's a single universal vibration at the tiniest possible scale, and that one oscillation is the source of literally everything, every particle, every force, and yep, even space and time themselves. So, how in the world does this cosmic heartbeat actually work? Okay, imagine a clock ticking at a speed that is just unimaginable. With every single tick, or loop, a tiny, indivisible little chunk of new space is created. At the same time, time itself moves forward by one single, indivisible moment. According to DLM, reality is literally being woven together, beat by beat, at a rate of 10 to the 43rd power every single second. It's just staggering. Okay, but before we go any further, we have to talk about that giant roadblock that stops so many other theories, those pesky infinities and zeros. In physics, when your equations try to divide by zero, like if you shrink a space down to zero volume, they just explode. They go haywire. That's what creates the whole singularity problem in the first place. DLM has this really clever way of getting around this, an idea called the two calculators. For all of our normal, everyday physics, you use the standard calculator. That's Einstein's equations, quantum mechanics, all the stuff we know works. But for the absolute extremes, like the origin of the universe or inside a black hole, DLM says you switch to a special no-zero calculator. Its one rule is that it never, ever allows a true zero. It always replaces it with a tiny minimum value. And the result? The equations never break. Singularities just can't happen. So by neatly sidestepping those mathematical traps, the theory is now free to make its most powerful claim, that all of the crazy complexity we see in the universe actually comes from one single, unified source. And that source is called the phi field. I want you to think of it like a universal ocean that fills all of existence, every nook and cranny. But this ocean isn't calm. It's always oscillating, vibrating at that fundamental frequency. In DLM, this single field is the ultimate substance of all reality. And I mean, everything we observe is just a different manifestation of this one field. Gravity, the particles that make up you and me, that mysterious dark energy that's pushing our universe apart, they're all just different behaviors, different ripples in the phi field. It's the ultimate unification. But hang on, how can just one field create so much variety? The theory uses a beautiful analogy, A violin string, right? A single string can play a ton of different notes, harmonics, depending on how it vibrates. Well, in the same way, the phi field's oscillations can have different harmonics. An electron is like one note. A heavier quark is like a higher frequency note. And their masses aren't just random. They emerge naturally from the math of these harmonics. So, with this whole unified picture in place, DLM can now offer a completely new story for the birth of our universe. It replaces the Big Bang with something, well, something else entirely. Instead of the Big Bang, DLM proposes the hydronova. So, where the Big Bang is this chaotic, violent explosion from an impossible point, the hydronova is a smooth, vigorous swelling of the phi field itself. The Big Bang needs to bolt on a separate theory called inflation to make the numbers work. And the hydronova, that rapid expansion, is just a natural consequence of the field's own energy. And the most important part, no singularity. The universe begins with a finite loop of energy. And what's so elegant about this is that this new beginning seems to solve some of cosmology's biggest head-scratchers, just right out of the box. Like, why is the universe so uniform on large scales? Well, because the phi field was oscillating everywhere at once, smoothing everything out from the start. Where did all the matter come from? It just condensed out of the field's energy as things cooled down, like dew forming on grass. And dark energy? DLM suggests it's just the faint leftover hum from that initial oscillation, still gently pushing everything apart today. Okay. This all sounds incredibly neat. Almost too neat. But an idea, no matter how cool it sounds, is not a scientific theory unless it can be tested. So, why should we actually take DLM seriously? Well, the answer comes down to its concrete, falsifiable predictions. See, this theory doesn't just offer cool explanations. It makes very sharp, testable predictions. It predicts a very specific and kind of weird mass ratio for neutrinos, 1 to 3.1 to 49. It predicts that when black holes merge, they should create these gravitational wave echoes at a particular frequency. And maybe most impressively, it makes precise predictions about the fundamental constants that govern our entire universe. And this is where it gets really compelling. Without any tweaking, without any fine-tuning or fudge factors, the theory's basic equations predict key values for our universe right from first principles. Its prediction for the Hubble constant, that's the expansion rate of the universe, is stunningly close to what we've observed. The same thing goes for the temperature of the cosmic microwave background radiation. Getting these numbers right without cheating, that's a huge deal. But maybe the most exciting prediction is this number right here. 250 hertz. DLM predicts that after two black holes merge, we should be able to detect these gravitational wave echoes ringing out at around this very specific frequency. Our observatories, like LIGO, could actually hear this. Finding that signal, that would be the smoking gun. It would be tangible proof that space-time really does have this loopy, oscillatory structure that the theory describes. In the end, the real appeal of Duhon's looping motion is just how powerful its simplicity is. It kind of reminds you of that famous idea from Einstein. The theory tries to explain our entire complex cosmos, not with a dozen different ingredients and patches and fixes, but with one single fundamental principle. And that leaves us with a final, kind of beautiful thought to chew on. Could it really be that everything we see, from the smallest particle to the biggest galaxy cluster, isn't a collection of separate things at all, but just the rich and complex harmonics of a single fundamental note, playing an eternal looping song? According to DLM, the answer is yes. And now scientists actually have the predictions they need to go out and listen for the music.